Okay, so hi everyone. In this video, we will discuss the isotomes. So, what are the different isotomes? With the latest example, we will discuss in this lecture. Let's see. So, today's topic is isotomes. Isotomes, and these are the very important. Okay. So, what are the isotomes? So, we'll cover in this lecture. What are the total iso means what? Iso means equal, same. Okay, iso means equal or same, we can say. Okay, so what are the isotomes? First we will see isotopes. Okay, so isotopes is nothing but iso means equal. So what will you equal? The species which has same atomic number, but different in their different in their mass number, that means a. Okay, so atomic number z value. Okay, already discussed how can we represent an element. Okay, so example, hydrogen has three isotopes, H11, H12, H13. This is called protium. First one is called protium, and H12 is called deuterium. Okay, deuterium represented by D, and this is called tritium. Okay, so here these are the atomic number. This atomic number is same, yes or no? Atomic number is same, but atomic mass, but in their atomic masses, the atomic masses is difference. Okay, so we already know how to element represent. If x is the symbol of the element, z will be atomic number, and a is what? Atomic mass. Okay, we have already discussed. Now one more example we can discuss. Carbon has three isotopes. What are these? Carbon 612, carbon 613, carbon 614. Okay, so these are the three isotopes. So the 6 is atomic number of carbon. So atomic number is the same, but different in their atomic masses. 12, 13, 14, these are the atomic masses. Value of a atomic mass represented by, and these are the atomic numbers. Okay, so next, so second one, isobar. So isobar is what? Isobar is nothing but the species which has same atomic mass but different in their atomic number. Okay, same mass number but different in their atomic number. See, what is the example? What are the example? Let's see. Okay, H13, H23. Okay, so here mass number is same. This is the isotope of one of the isotope of helium. We are comparing in between. Okay, so isobars. Okay, same mass number but different in their atomic number. Okay, so mass number is the same, tritium and helium 23. Okay, so atomic number different, atomic mass or mass number is same. So mass. One more example. Example 2, potassium and calcium. So it's 1940 and it's 2040. Okay, so atomic number is atomic number is different but mass number same. So in this case, one thing we have noticed, we are noticing one thing here. What you notice? Tell me, bro. Tell me, bro. Okay, same number of mass number, same atomic number, or what? Atomic mass. Okay, so same atomic number, that means value of A, but different in their atomic numbers. Okay, so one thing we are observing here, it means that is they have different number of electron, proton, neutron, but 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 sum of neutron and proton number and proton have, but sum of neutron and proton is same. Okay, is same. That means that is what? N plus p value, n plus p same. Okay, let's see how. In the first case, H13 helium 2 3. Okay, so it has electron. Check number of electron equal to 1. Proton 1. Neutron which what? A minus z. Neutron is A minus z. So what will coming out? 3 minus 1 equal to 2. Okay, so now we have to add. In this case, n neutron plus proton, number of neutron plus proton. What is the neutron? 2. What is the proton? 1. So equal to 3. So for H13 we get new number of neutron plus number of proton is coming out 3. So let's check in this case. So in this case, electron equal to 2, protons are 2, neutron will be, sir, 3 minus 2 equal to 1. Therefore number of n plus proton equal to what? What is the neutron? 1 plus proton 2 equal to 3. Now check it out. Okay, so in H13 the number of neutron plus number of proton value is same. That means sum of number of neutron plus number of proton is same. In this case also same. Okay, the n plus p value. Okay, now you can check yourself in this case potassium and calcium. Hope is it clear? Hope is it clear to everyone? Okay, so what is the next? Isotope, isomer. Next is isodiaphers, right? Yes or no? Next is isodiaphers, isotope. Okay, so last is isodiaphers. Okay, so isodiaphers means what? They are the atoms of different element, okay, having the same number of, or that means sum of the n minus p value. Okay, same number of n minus p value. They have atoms of different elements. Okay, they have the atoms of different elements and they have n minus p. They have same value of n minus p. That means difference. They have same value of value of n minus p. Okay. Okay, so let's see what are the examples. Okay, so one example we will take boron and carbon. Boron has 5, 5, 11, 6, 12. Okay, these are the atoms of different elements. They have same in many space. So let's check. So in this case, in the first case, so in this case, electron 5, sir, proton 5, neutron 11 minus 5 बराबर 6. Therefore number of neutron minus number of proton बराबर neutron 6 minus proton 5 equal to 1. Okay, but in this case, let's check. Electrons are 6, proton 6. What is the neutrons, sir? 12 minus 6 barabar 6. Okay, therefore difference in number of neutron and number of proton equal to what? 6 minus, okay, minus 6. Okay, okay, so okay, we can take it. So what we will do, because if we comparing between two elements, okay, they have the n minus p value is not same. Suppose we will, okay, we can do it 6, 13. Okay, so if it will be 3, if it is 13, what happened, that means 13 minus 6 barabar 13 minus 6 barabar, so 13 minus 6, yes or no? So 13 minus 6, 7. So it is coming out 7. So neutron comes 7 minus proton 6, it is 1. Okay, now done. Okay, so the they have the same value of difference in number of neutron and proton. Okay, n minus proton, that means number of neutron minus number of proton is the same. One more example, if you take, we can do yourself the example I am doing here. Okay, so example 2, we can take nitrogen and fluorine. So nitrogen is 7, 14, this is 9, 19. Okay, so 7, 14. Okay, what is the isotopes of nitrogen? 7, 14, yes or no? Other, okay, one more isotope, it is also, okay, now check it out. If you check in this case, sir, it has electron equal to 7, proton equal to 7, neutrons are kitna 15 minus 7 equal to what? 8, yes or no? Now in this case, in this fluorine electrons are 9, proton also 9, and neutron will coming out 9, 10 minus 9 equal to 10, equal to 10. Okay, therefore what we can check, therefore number of neutron minus proton equal to, what is the neutron? 8 minus proton 7, so 1. In this case, number of neutron minus number of proton equal to 10 minus 9 equal to 1. So we get the same value in the difference of number of neutron minus number of proton value. Okay, so these are the called isodiaphores. Okay, these are the isodiaphores. Okay, so these are the